In this video on probability, we'll be looking at sample spaces. So first of all, let's define what a sample space is. And a sample space is the set of all possible outcomes. There are three types that we encounter on our course. First up, we have the list. We only tend to use this in very simple situations. And generally, it's when only one thing is happening. So I'm rolling a dice and observing the outcome, or I'm selecting one marble from a bag, or I'm flipping one coin and seeing what the outcome is. Next, we have the two-way table. And a two-way table is a grid that we use generally when there are two events occurring. So maybe I've got two dice and I'm rolling them both simultaneously, or I'm flipping two coins. Or maybe I'm even rolling a dice and flipping a coin together. I can't use a two-way table for more than two things happening in combination. A tree diagram is a diagram that we can draw for two or more things happening at the same time in probability. So it can be used instead of a two-way table to represent two situations occurring, but it can also be used to represent three or more. So let's go through these one by one, and we'll start off with a list and we'll have an example. When I spin this spinner, and the answer here is pretty obvious. It's yellow, pink and orange. I can see from the spinner that all the portions are the same size. I've got three equal sectors. So these three outcomes are equally likely. I've got equally likely events. This makes it very easy to write down the probability of each of these individual things happening. So take a moment now to write down the probabilities of each of those. The probability of spinning yellow, of spinning pink and of spinning orange. Pause the video while you do that and then play and see if you're correct. And see, are there any other observations that you can make? So in each case here, the probability is 1/3. Remember that we mentioned in the last video that if we've covered all possible eventualities, the probabilities should sum to 1, and here we can see that they do. So of course 1 represents certainty and probability. So what's certain here with this 1? Well, it's certain that I will either spin a yellow, a pink or an orange. Now here's a question for you. A coin is flipped. Make a list of all the possible outcomes. So this one's very straightforward again. Here the possibilities are heads and tails. We can abbreviate this if we wish to H and T. And there's no problem generally abbreviating like this in probability as long as it's clear what your abbreviation means. And if it's a little bit touch and go on that, then maybe it's a good idea to include a little key at the beginning to indicate what your letters stand for. But usually in things like heads and tails, H and T fairly obviously stand for those. So here are 3 short questions then to complete on this one. So pause the video for a second while you give this a go. Okay, so the first one is just simply the probability of heads. Note again here, of course, that flipping heads and flipping tails is considered to be equally likely. I've got the same chance of each of those happening. And so the probability of getting a heads is 1/2. This is sometimes described as even chance. Next, we have some notation. So we've got the probability of T complement. That's the same as saying the probability of not flipping and getting a T, not getting tails. Well, that means we're getting heads. So again, it's 1/2. And in our last question, again, this is a bit of set notation. This is our union symbol. We saw in the last video that this actually represents the word or, so the probability of heads or tails. So I can add their two probabilities and note there's no overlap in this case, so no need to subtract. And the probability there is 1. And of course that makes sense because if I flip a coin, then it's certain that I'm going to get heads or tails. So it's rare enough that we're ever asked to just make a straightforward list as a sample space, but it can be handy for ourselves just to keep track of how many outcomes there are and what the favourable outcomes are. Here's our second example. In this one, 2 coins are flipped and we want to show the outcomes using a two-way table. So of course, in this question, there's 2 things happening, and so it makes sense to use a two-way table to represent that. And again, a two-way table is just a grid that allows us to fill in all the different situations that are going to occur. And in this case, my grid will look like this. I'll write the outcomes for the individual coins on the outside of the grid. And so that I'm clear which one's which, I'll label these coin 1 and coin 2. Then I'll fill in the individual outcomes for these on each side. So obviously when I flip coin 1, I can get heads or tails. So I'll note that outside the grid. And it's the same for coin 2. And then I'll just simply combine these to fill in the inside of the grid. So for example, in the first box, I'll be filling in HH for heads and heads. In the next box, I'll be filling in HT. So this just represents that I'm getting heads on coin 1 and tails on coin 2. If you like at this stage, you can pause the video and complete this table yourself. So in this box, it'll be TH. And then in the last box, TT. A quick note on the pros and cons of two-way tables. They show two events clearly. I can easily see all outcomes, and I can easily pick out my favourable outcomes. The cons are that I can only use them for two events, and that we tend to only use them for equally likely events. So for example, in the case of the coin, the heads and the tails are equally likely to happen. Same for coin 2, and this means that all my entries in the table are equally likely. So let's use this two-way table then to do a couple of calculations on probability. So there's two questions here. First of all, to find the probability of two heads. So I simply look at my two-way table. I see that there are 4 possible outcomes because there's 4 boxes in the grid. One of those boxes contains 2 heads. So I've got 1 favourable outcome out of 4. Secondly, we've got heads and tails in any order. So that means it can be heads, tails or tails, heads. So let's have a look. We've got, again, 4 boxes, obviously. And in this case, there's 2 of those that are favourable. So I've got a probability of 2 over 4. You can cancel this to a half if you like. So here's your question. A coin is flipped and this spinner is spun. Draw a two-way table to show the outcomes. And just for clarity here, each of these sectors is of equal size and the colours are pink, orange and yellow. Pause the video here, go ahead and draw the table and then play and see if you're correct. So I've drawn my grid. Notice that I've left 3 spaces across the top because I've got 3 options in the spinner and then 2 down the side for the coin. And of course, I could also do it the other way around if I liked, with coin across the top and spinner down the side. It makes no difference as long as all the outcomes are shown. So again, I'll fill in the individual outcomes on the outside. For the coin, that's H and T again for heads and tails. And for the spinner, I've got orange, yellow and pink, and the order here doesn't matter. So let's fill in the grid. On the top line, we've got HO, HY, HP, and on the bottom, TO, TY, TP. So for example, TO means I got tails on the coin and orange on the spinner. So here are 4 quick questions for you now to do. Pause the video here, answer these, and then play and see if you're correct. So for the first one, probability of heads and pink. Well, I've got 1 favourable outcome out of a grid of 6. So the probability is 1 over 6. For probability of getting tails, well, there are 3 boxes that have a favourable outcome for that. So 3 out of 6. For the probability of not pink, well, I've got 1, 2, 3, 4 boxes that don't have pink in them. And there's 6 boxes overall. So 4 and 6. And finally, the probability of getting tails in the coin and yellow on the spinner, well, I've got TY in this 1 box. So again, 1 out of 6. In example 3, we're going to look at a tree diagram example. Now, tree diagrams can be used for more than 2 things happening, so I can use them for 3 or 4 things happening, but just to keep it simple for our first example, I'll just do it for 2 events again. So I'm going back to actually example 2. It's the same example that I used for the two-way diagram, or the two-way table. 2 coins are flipped, and we want to draw a tree diagram to show the outcomes and probabilities. So the first thing to note with tree diagrams is that layout matters. And I'm always going to start a tree diagram by partitioning up my page, just dividing it up. And I'll divide it into columns, and I'll have columns to cover each of the different things that are happening. So I'll have a column for each of the coins that are getting flipped. Then I'll have a column for the outcomes, and then I'll have a column for the probabilities as well. So decide how many columns you need at the beginning, then draw them, and then we'll get stuck in. And I'm going to put a heading in on each of my columns. So I'll have coin 1, coin 2, outcomes, probabilities. I like to mark a dot about halfway down my first column for my starting spot. And my tree diagram will begin from here. So I'll start drawing branches, and I'll draw the same number of branches that I need for the different possible outcomes for the event. So for coin 1, I'm going to flip that. I can get 2 different outcomes. I can get heads or tails. So I'll have 2 branches. And at the end of each branch, I'll put a bubble, and in that bubble, I'll write the outcome. So in this case, it's just heads and tails. But what's nice here is that I can put in an additional piece of information. So along each of the branches that I've drawn, I'm also going to fill in the probability of that particular outcome. So for example, in the case of heads in the first coin, well, I've got a 1 in 2 chance of getting heads. So I'll fill that in there, and I'll do the same for the probability of getting tails. So this is what's particularly nice about a tree diagram over a two-way table. It allows me to incorporate the probabilities as I go through the diagram. And while these two events, heads and tails, are equally likely, just like in the two-way diagram, they don't have to be in a tree diagram. They can be different probabilities depending on what's going on. Okay, so I've flipped coin 1, and there's two different things may have happened. I may have got heads or I may have got tails. If I got heads, I'm going to flip my coin again, regardless, and well, flip coin 2, and I'm going to see what happens with that. And when I do that, there's going to be two possible outcomes for coin 2. So I'll have two branches coming out of the heads. And just like before, I'll put a bubble at the end of each. And in the bubbles, I'm going to fill in H and T, because I could get heads and tails on that second coin as well. And of course, it doesn't really matter what the outcome was in the first time round with coin 1, because even if I got tails in the first coin, when I flip again, I could still get heads or tails on the second coin. So again, I'll draw two branches coming out of that tails option. And again, at the end of those branches, I've got the bubbles. And since coin 2 can end up giving us heads or tails, I've filled in H and T here as well. And I'm also going to go through each of these and write in the probabilities. So no matter what happened first time round with coin 1, when I go to flip coin 2, I've still got a 1 in 2 chance of getting heads. And that's true whether I got heads first time round or tails first time round. So I can fill in a half on each of those branches. And the same is true for tails. Whether I got heads the first time or tails the first time, the chances of getting tails the second time round are still 1/2. So now I've got all my information for my first two columns filled in. I'm going to go ahead now and fill in the outcomes column. So to fill in the outcomes column, I'm just going to follow each possible pathway through my tree diagram and then write out the outcome at the end. The first set of outcomes is HH. The next is HT, then TH, and then TT. And now for the probabilities. I'll fill a probability in for each of the outcomes that I've listed here. And to decide on the probability, what I'll do is I'll follow those same paths again. And as I go along them, I'll multiply together the fractions that I encounter. So for the first one, I've got a half times a half. The probability will be 1/4. For the next one, heads, tails, let's follow that. A half by a half again. And again, it'll be 1/4. And actually, in this case, they all end up being 1/4. This won't be the case in every tree diagram that you draw though, so just be aware of that. And once I've filled in all my probabilities, it's a really good idea to total them up. And you should find that if you've completed your tree diagram correctly, that the total is 1. And again, of course, 1 in probability is certainty. So what's certain here? Well, what's certain is that I'll get one of these outcomes from the list. So let's do a couple of questions then based off this tree diagram. Let's first of all find the probability of heads and heads. So in this case, I just go and have a look for the outcome, heads and heads, that's fine. The probability is 1/4, I have my answer. Next, let's find the probability of heads, heads, or tails, tails. And you might remember from our previous video that when we see the word or in probability, it kind of gives us a hint to add. So in this case, we're looking for heads, heads, plus tails, tails. So I can simply go and select these probabilities from my list from the tree diagram and then add them together. So in this case, 1/4 plus 1/4, and the answer is going to be 2/4. And finally, the probability of not getting tails and then tails again. So in this case, we can simply go and select all the outcomes that aren't tails, tails, and add them all together. And in this case, the answer is 3/4. So just note that if you're selecting multiple outcomes, add the probabilities. So here's your question. A coin is flipped and this spinner is spun. Draw a tree diagram showing outcomes and probabilities. Pause the video here, complete your diagram, and then come back and check and see if you're correct. Okay, so I have my layout complete first of all. I've got 4 columns, one for the coin, one for the spinner, one for the outcomes, and one for the probabilities. I'll put my dot about halfway here just to position myself well, really more than anything else, and then I'll start drawing my tree diagram. So the coin has 2 outcomes, so 2 branches, a bubble at the end of each for H and T, and then I'll also include my probabilities along the branches. Next, I move into the spinner column. Now, notice how there are 3 outcomes that are possible for the spinner. So that means that I should have 3 branches coming out of heads and 3 branches coming out of tails. And again, a bubble at the end of each of these, and then the outcome noted in the bubble. And of course, if I got heads the first time and I spin the spinner, I can get orange, pink and yellow. And the same thing happens if I got tails the first time. I can still spin the spinner and get orange, pink or yellow. Again, I'll fill in the probabilities along the branches. It's 1/3 for each of the sectors in the spinner. And that's the same whether I got heads first time or tails first time. Now I list my outcomes, and there are 6 outcomes. And now I'll fill in my probabilities, and to do that, I'll multiply as I travel along each branch. So for the first one, the probability of getting heads and then orange on the spinner is 1/2 multiplied by 1/3, and that's 1/6. And in this question, because the values for the coin's outcomes are both the same, and because the values for the spinner's outcomes are all the same, I'm going to get the same probabilities the whole way down. But again, just to emphasize, that won't necessarily happen every time in a tree diagram, because you can have different probabilities through the diagram. So now I've got a probability for each of my outcomes. And again, I should just total these probabilities up and be sure they equal to 1 to know that I'm doing it correctly. And in this case, I get 1, so I'm happy with that. So here are 2 questions for you now based on this tree diagram. So pause the video here again for a second and see how you do with those. Okay, so for the first one, the probability of getting tails on the coin and orange on the spinner, well, I can see that that outcome is listed here, so I just have to go to it, check its probability, and that's my answer. So 1/6 in that case. And for the second one, the probability of getting heads on the coin and pink or yellow on the spinner, well, there's a couple of different outcomes that works for. So I'm looking at HP and HY, and since there's multiple outcomes there, I'll go to their probabilities and add them together. So in this case, my probability is 2/6. So just to recap, this is all about sample spaces, which are the set of all possible outcomes, so all the different things that can happen in a situation. And we can see them as lists in very simple situations, as two-way tables, and as tree diagrams, and we can use them to calculate probabilities.